Welcome to this guide on how to set up multiplayer using Unity Kinematic Character Controller with Netcode for GameObjects using Server-Authoritative movement as well as client-side prediction. In this tutorial, we are going to be actually implementing the networking part of the Kinematic Character Controller. So just to refresh your mind, we have the server. We have two clients that will connect to the server. This is client 1. Client 1 can move, can run. Well, this is other things that you can implement that I can't teach you how to do it, but this would now be inside my course on how to create a multiplayer game using, well, Unity Netcode for GameObjects and the Kinematic Character Controller. If you wish to learn that, stay tuned. Excellent. So we have one client, we have the server, and we have another client. Client 1 can look at client 2. We have animations. We even have combat, but that is way not in the scope of this tutorial. So we have the clients. Both clients can see the movement. Check it out. There is no lag in the input. That's because we are using client-side prediction, and the server is witnessing everything that's going on in the game. Perfect. We're going to achieve this topology in this video, so let's get started. All right. In the last video, we left off with our movement for the character. We have the actual movement. We can move, we can jump, we can double jump, and we can wall jump. Now we are interested in the networking side of things. So let's get started with networking. First, let me explain you very fast how this works. You have a server. This is the server. Let's make it like a little computer, like a little PC. This is the server. So the server is like when you run a Minecraft server, a PC that is running your code for, well, the logic of your game. Other computers will connect to the server. So this is your client. Client 1, client 2. PCs that connect to the server are called clients. So we have client, in this case would be client 0 and client 1. Client 0 and client 1, like we saw in the example at the beginning of this video. Client 0, client 1, they are both connecting to the server. Okay, they connect to the server. Any input that we pass to the server, so you connect, the server connects you, and you are now spawned. Now, whatever input you press on your keyboard, if we're using a server-authoritative movement, this means it's going to be really hard for hackers to actually hack the game and move however they want, because any movement will be passed onto the server. So if you move, if you press the W key, this will go onto the server. The server will process the movement and will be returning the value to your client, and therefore also replicating that movement to all the other clients so they can see that actually client 0 has moved. All of this will take time, and that is the issue when you have server authoritative movement. That's where you have the input lag. You press something, and after a second or half a second, you get the movement, and that's the issue. And that's why we are going to fix this using client-side prediction, which actually only means the fact that when you in the client 0 move, you will start moving without having to send information to the server. Information will be sent to the server, and the server will replicate this movement to other clients. The meaning of client-side prediction in this case is that your client will process your movement without the need of the server actually processing it, and the server will process the movement. And if your movement is not the same as the server movement, the server will compensate and fix the issue and have the authority over the movement. That's why hackers won't be able to simply use cheat engine to move faster in your game. All right, so that's the topology we will be working on. Let's first get started with netcode for game objects. So let's get started. Now, let's first focus on our hierarchy. We have the environment and we have the player, right? The player was defined on the last video. We're now going to set up a new empty game object, which will be called the network manager. All right, the network manager will be in charge of handling everything related to multiplayer. So this network manager is a component that we will add called network manager. All right, here first it says you need to select a transport. We're going to select Unity transport. All right. Now this also says access additional tools for multiplayer by installing multiplayer tools package. We're going to leave this notice because later on we will install the multiplayer tools. It's very useful. So let's focus on the network manager. We get the protocol version, the network transport, which is pointing to the network manager Unity transport component that has just been added. Then spawn timeout, connection approval, recycle network IDs, RPC hash size. I'm going to leave everything as is. The only thing you need to focus on is the network prefabs list. This is a list that has all the prefabs that are networked. And as we move all along on the multiplayer side of things, you will see how this gets populated. So let's leave it like it comes, the network manager as is. The Unity transport as well, just leave it like it is. You don't need to actually tweak anything. Not for now. So network manager and Unity transport done. Next, we will set up the UI. So this is the UI with a few buttons, so we can easily have the start host, start server, start client. Okay, this is for debugging purposes while we are working on the game. So right click the hierarchy UI and let's add a canvas. All right, let's name it UI and place it on top of the environment, and the event system can go inside the UI. So we have the UI canvas, we have the canvas, and we have the event system. Right now, this actual UI needs to be called canvas, and let's create a new empty game object called the UI. Let's reset the transform. Let's place the canvas inside the UI, and let's place the event system as well inside the UI game object. There you go. Now inside the canvas, we need to modify some things. First of all, the canvas scalar and the canvas itself. The canvas itself has a screen space overlay. That's fine. Vertex color always in gamma color space. We're going to set it to true. Okay, we set it to true. Then the canvas scalar. UI scale mode will be set to scale with screen size. Now the default screen size will be 1920 by 1080. You can modify it as you wish. Screen will match width or height. Okay, now the match will be either the width or the height, and in my case I want to match the height, so the value will be 1. Perfect. That's it for the canvas. Then you have the graphics raycaster, which doesn't need anything. So that's the canvas. Now inside the canvas, we're going to add 3 buttons. All right. So we right click the canvas, we go to the UI, and we add a button, text mesh pro button. Click that, and a new pop-up will appear with TMP imported. importer, import the essentials. Let's wait for this to finish. Alright, now that the essentials have been imported, you don't need to import examples and extras, just the essentials. Okay, now here's our button. We're going to click on the 2D view. We're going to double click the UI, and here we have the button. We're going to place the button somewhere on our screen. In my case, I will place it right here, like this. Okay, perfect. This is the button. Now, the value of the button, the text, will be inside the actual button. We have the game object of text, and we're going to change this to host. This host means you are the player and the server at the same time. All right, this is the button for host. We're going to say start host button. This is the name of the component of the object. Perfect. Now we're going to duplicate the start host button and drag it a little bit down, perhaps like this. Some more spacing. There you go. This will now be the start server button. So start server button, and we just need to modify the text to server. All right, now duplicate and move it along, and we're going to have now the start client button. Start client button. So for the client button, we're going to modify the text to say client. Perfect. We have the start server, start host, start client. Now, for the logic, we are going to create a network manager UI script. So create a folder called multiple netcode. Perfect. Create a folder inside scripts, name it netcode, create a script, model behavior script, and we will call it network manager UI. All right, so let's get the network manager UI script opened. So let's wait for the compilation to finish. Great. Now open the network manager UI and let's get started. We will be using three things: Unity Engine, Unity.Netcode, and Unity Engine.UI. We will reference three buttons. So starting off, we will set public, GameObject, start host, server, and client. Then in the start method, we're going to assign the methods. So we're going to say start. Now, if the start host button is not null, we will say start host button dot get component button on click dot add listener and the code for starting the host. The same for start server and start client. Now, below, we're going to define the three methods: start host, start server, and start client. Now, start host will make use of network manager.singleton. Remember the network manager we define at the start of the scene? Well, it's a singleton, so it's always available. And we will call the start host method. And that's it. Now, for visual purposes, we will go into debug using debug.log, host started, and we're going to change the color of the button so we can visually know who is the client, who is the server. So for that, I have a helper method called change button color. Copy and paste this code to change the color of the button. All right. And the color we will give it, in this case, will be green, and you can change that however you want. We are also going to disable other buttons, so we are not able of switching mid-game. And this is how we disable. We just make it interactable false. Okay? That's it. That's all you need for the Network Manager UI. Now we're going to assign this component to the UI game object. So for the UI game object, we assign the network manager UI and we assign the references for our buttons. Start server, start client, and that's it. We're going to save. Now we will go to network manager and remember the multiplayer tools. Well, I really recommend you download them. Now there's a catch. If you have, I believe, is the modern disk drives, it won't work. You can still try it out. But if it doesn't work, well, the way for it to work is by building the game. Anyways, let's go to the package manager and let's look on the Unity registry for multiplayer. And let's download multiplayer tools. So let's install that. All right, it has finished installing. Let's leave it as is. Later on, we will use it. Now we have set up the UI. Then the next thing would be to set up the player. So this is where we will need to make a few changes to our scripts and to the player itself. So the player is the uppermost parent of the hierarchy for the character. You have the player, you have the camera, you have the character. Both camera and player will be both camera and character are part of the player. So the network object will be the actual player. You only define one network object per game object, that is the parent. Anything inside the parent cannot have a networked object unless you spawn the network object and set parent, but that is another story. We're not going to do that in here. All right, so the player will be assigned a network object. So let's now assign a new component called the network object. As for the network object, we're going to always replicate as root, synchronize transform, then syn migration synchronization can be set to true or to false. Spawn with observers is true, and auto object parent sync will be true. So this network object is the player. So let's assign that. First, in the assets, we need to create a folder for prefabs. And inside the prefabs, we're going to drag and drop the player. That's the player. Now, as for the network manager, we need to set a default player prefab, and that will be the player that has the game object, the network object. So we can now delete the player from the scene. We will fall back to the server camera. Now, the player is now a prefab, contains a network object, the player input, and the input manager. So now we need to work on our scripts so we are able to actually network everything. The first thing we will do is test what is going on. Let's click play and let's click on host. We should be able to see a character spawn and everything works like it normally did, because when we are the host, we are running the code locally and making everything available for users to join. That's why when we play as host, there's not much we need to do. The issue comes when we want someone else to join. So to test this, we're going to go to window. It is inside somewhere in here. I believe it's inside window, then multiplayer and multiplayer tools. Then this pop-up will appear and we will set the we need to set up so we can have 2 players running. And it's not the tools that we need, we actually need multiplayer play mode. So multiplayer play mode, we install it. So with multiplayer play mode, we go to window, multiplayer, and we select multiplayer play mode. And this is where we are going to select 2 players. So we need to save, we select player 2, we wait let everything compile, and let's test. So a window will appear with another game inspector window and another console. This console is particularly useful for this client. Okay, it will help us debug what's going on client side. We can close multiplayer play mode and we will always have this window available. Okay, so now that we have the player 2 and the player 1, we can press play. When we press play, both player 2 and player 1 will be playing. Now, as for player 1, we will be the host. So this is player 1, we are host. We move, and let's see what happens with the client side. As you can see, another client has joined, but when we move the client, we can notice that both players are moving client side because the host is not seeing that happen. Now, if we move the host, you can see that the client is also moving. This is because the camera is working for both players. Now, that's the first thing we need to fix. We need to make the camera work only for our instance of the client. So, to fix this, we stop the game and we go inside our player and we go to the camera inspector and we open the character camera. Now, the first thing we need to do with the character camera is to set up everything as a network behavior, not a mono behavior. So network behavior, control space, and we import Unity.Netcode. All right, network behavior behaves the same as mono behavior, but with the difference that it has a few built-in methods that are used in multiplayer. First of all, the first thing we need to do is to tell the client to only handle their camera and not other players' cameras. To do that, after all the private variables and the onValidate method, we are going to modify the awake method, right? We are gonna modify the awake method. So we will define on network spawn. So this will be a public override void on network spawn. Perfect. So on network spawn, we are going to call the initialize method that we are going to define now. So this will be private void initialize and open brackets. So as for the initiation, we will first define if we are owner. So we say if is owner, and this is a condition we have available due to the network behavior. Is owner will check if we are running as the local instance. So if we are the client owner of this client. So if we are the owner, the camera, the main camera, so if owner, main camera will be equals to camera.main. Update with input, set follow transform, and we will then work on the awake method. So if we are owner, the main camera will be camera.main. And if, let's now fix the audio listener part of things. So if main camera is not null and main camera is not the camera, then we will define the main audio listener. So audio listener, main audio listener is equals to main camera.getComponent audio listener. And if audio listener is not null, if main audio listener is not null, then main audio listener dot enabled will be false. And now the camera tag for the main camera, so main camera dot tag will be untagged. Then the camera, then the tag outside of the if statement, the tag for the camera will be main camera. Okay. Then we also define the audio listener again. but our audio listener, that is our audio listener as the client, and our audio listener, if it's not null, then enabled will be true. Okay, what have we done in here? Remember, the server has an audio listener, and we as clients, we don't need that camera, neither the audio listener of that camera. That's why we define this code in here. Next, if we are owner, we're doing this. Else, all we need to do, if we are not the owner, well, camera.enabled will be false. Audio listener of our audio listener will be equals to camera.getComponent audio listener, and audio listener enabled will be false. Then we can see that the awake method is running a few things like the transform, the current distance, the target vertical angle, the planar direction, and everything we're going to copy, and outside the if else statement we're going to paste it, and we're going to delete the awake method, and that's it. We have now set up the camera for multiplayer. We could continue working on this camera, and we will when we work on the RPG game, wink wink, Udemy course. All right, so let's now check the camera. Now, if we press play, we should be able to control our own camera and only our camera. Let's check it out. Let's go to the scene. Let's clear the console, press play. Let's be the host. We are the host. We move a little bit. We control the camera. Perfect. Now we go to player 2 and we join as a client. We are, as you can see, as a client, we are controlling both the host and our camera. But as the host, let's now fix that. The issue is within the input manager. Okay? Now, in the input manager, the late update and the update method need to return null if we are not the owner. So the simplest fix and what you need to do is to say, if we are not the owner, we return. Same for the update method. If we are not the owner, we return. And remember, we need to set this as network behavior. We import Unity Netcode. We save the input manager, and now it will work. Let's test it out. So we press play. We start the game as a host. We control our camera. We join as a client. We try to control our camera, and we are only controlling ourselves, our camera. Notice that movement is not being replicated. That's fine. We will now work on it. And as for the host, the same. We are only controlling our camera, and that's perfect. We have now set up multiplayer camera. We now need to set up the movement. So let's inspect the input manager. We have already set up if is not owner return for both the update and the late update, which will in part affect the character input, the non-mobile input, and the camera input. Perfect. I believe everything is done inside the input manager and the character camera. Now we need to work on the Locomotion controller. As for the Locomotion controller, there is not much we need to do, but we do need to set up a few things. First of all, let's not forget to change mono behavior to network behavior and import Unity.Netcode. Once we have done that, the first thing we are going to do is we are going to handle the definition of our character. So we have the set inputs after character update and the other methods. Right. On the start method, we have set that motor.characterController is equals to this. Now, to make this work, all we need to do is change this value to the following. If we are the server, if is server, then only the server will set the motor. And this is so the server handles every single movement. Now the client will not handle the motor. So the movement is happening on the server. Now we do else. If we are not the server, then motor.enabled will be false. Okay? And that's it. Now, as for the other part, we will need to work on a few things. But before we continue, we will need to implement the state machine. And this state machine is the one that is defined inside the example character controller. So let's do that first. If you follow along, we go to Assets, Kinematic Character Controller, Example Character, and set Example Character Controller. We go up, 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 and we have the default character state. We copy that, and we paste it in the Locomotion controller, anywhere above the public class. So we have the character state. Now, in the example, we also need to define the character state here, somewhere here. Public character state, current character state. We copy that, we go to our values, and we paste it. It was pasted below the miscellaneous, so let's paste it before the private variables. Okay, next, after that, the current character state is then used inside the awake method to transition to state. And let's just copy the transition to state, on state enter, and on state exit. Okay, let's copy those three methods. Let's go to the Locomotion controller and let's paste them below start. So we have transition to state, on state enter, on state exit. Now we need to make a few changes, some easy changes. The first thing is that transition to state. If we are the server, then we also need to say what state the character is in. So if is server, then network character state, that is a value that we need to add. So network character state, we will define a public network variable for it. So after character state, we're going to say public network variable character state is the enum we have defined. So character state, network character state is equals to network variable new character state dot default. All right. And this is so we can replicate the current character state of the client to all the other clients. So now we have the start method and we also have on network spawn. So on network spawn, if we are the server, we're going to say transition to state character state dot default. Then we leave the start method as is. Then in the update method that we're going to define now, so update method, we are going to define the network character state update. So network character state dot value is equals to current character state. And that's it. Then inside transition to state, we're going to say network character state dot value is equals to the new state. And there we go. One more thing, very important, this network character state inside the update method needs to be inside an if is server condition, otherwise it won't work. We are now going to test what we have made so far. So in window, multiplayer play mode, I am going to add a third player. This is going to be the main editor of the server and player 1 and player 2, because remember, we're doing a client server topology. Okay, so we're going to hit play as the server and we can see everything. Now we are going to open player 1 and player 2. Now if we join as player 2, you can see a player has popped up on the server. If we move, we cannot move. we are not being allowed to move, and that's what we're going to work on. If we click on the next client as well, you can see there are two clients on the server, but as a client we cannot see each other, neither we are allowed to move. So let's fix that. To fix this is where we are going to actually implement all the server authoritative movement and client-side prediction, and it's very easy. Well, it's easier than you'd think. So we need to set up a few more methods. Okay, so we have the set inputs method. So far, this works perfect for single player. But for multiplayer, we will need to set up a few more methods. So let's start by implementing a server RPC. The server RPC is whatever code we have, we will run on the server. So this will be a private void submit inputs server RPC. Now we're going to pass a float and we will submit the inputs we have. These are related to the player character inputs. So what inputs do we have so far? We have the move axis forward, we have the move float, move axis right, we also have the camera rotation, so quaternion camera rotation. All you need to do is come here and check quaternion bool and bool. Okay, quaternion, then quaternion here, quaternion camera rotation. Okay, then we have the bool for jump down and boolean for jump held, and then I will pass a sequence number. So int sequence number. Okay, and this is the server RPC. All right, now the next method, straight up we will define it, then we will come back here, is a client RPC, and this will replicate the code to all the clients that are connected. So we are going to do private void update client state client RPC. Remember, when you define an RPC, if it's a server RPC, your method needs to finish with server RPC. So this would be the submit inputs method, and the client RPC needs to finish with client RPC. So this is the update client. Now, as for the update client, we will have three values that we are passing along, and these parameters will be a vector3 for the server position, a quaternion for the server rotation, and the confirmed sequence. The sequence is for client-side prediction. Now, if we're not the server, we will return. Okay? Now, let's move on to the next method. The next method will be the process inputs method. The process inputs method. Okay? And that's it. We can now start working. It's going to be very easy. Okay? We will go step by step, so when you want to implement something else, when you add more functionality, you will know how to do it. Inside the set inputs, we will comment everything out. So we comment everything. All right? Perfect. Now, inside set inputs, we are going to check if we are the server or if we are not the server. So if we are not the server, we are going to apply inputs locally immediately, and this is for client-side prediction. So for client-side prediction, we apply the inputs immediately. And before we continue, we need to add a few enums. Well, we need to add one enum, which is the enum for client input, which is related to client-side prediction. So public enum client input, and here we have the public int sequence number and public player character inputs, call it inputs. Okay, that's the client input, and so good. So far, so good. Now we need to define the private variables for client-side prediction. And these are 3 variables in total. So after the jumping private variables, we're going to define the client-side prediction variables. This is a private for player character inputs, call it latest inputs. Then we have a list for client inputs, call it input buffer. And we have new list client input, like so. And then we have the local sequence. Okay, that's it. Now we need to go to the set inputs. Right here, we go to set inputs and we work on client-side prediction. For client-side prediction, remember, we are passing the inputs from the input manager. So for client-side prediction, we need to declare that latest inputs is equal to inputs. And then we call the process inputs directly. That's client-side prediction. Now we need to add a number to the local sequence. So local sequence plus plus. Then to the input buffer. So input buffer dot add new client input v2 brackets sequence number is equals to local sequence comma inputs, which is equals to the inputs. Okay, and then we set the input with the sequence number to the server. So after we set the input with the sequence number to the server, and this is where we will call the submit server RPC. So submit inputs to the server RPC. And what do we need to pass? Well, remember we have the inputs, and the server RPC expects the move axis, forward, right, camera rotation, jump down, and the sequence. So all we need to do is say inputs dot move axis forward, inputs dot move axis right. Then it was the camera rotation, so inputs dot camera rotation. Then we go to inputs dot jump down. Then inputs dot jump held, and finally the local sequence. And that's everything the submit server RPC is expecting. Jump down, jump held, sequence number. That's it. And then for the else, if we are the server, then the latest inputs will be equals to inputs, and we process the inputs. That's it. That's the set inputs method. Leave this as is because we will use it now. Just leave it there. As for the submit inputs server RPC, we are receiving these values and we are going to use them. Now, here we say player character inputs, and we define it, and now we use it. So inputs dot move axis forward will be equals to move axis forward, the one we're passing. And we do the same for move axis right, camera rotation, jump, and jump held. So move axis right, camera rotation, jump down, jump held. And that's it. As for the sequence number, we will pass it along. So that's it for the inputs. Now latest inputs will be equals to inputs. Okay, this is where the server is processing the inputs, and we process inputs. Right here is where we process the inputs. And now that we have updated the server, we need to update all the clients. So we call the update client RPC. As for the update client RPC, we will need the position and the rotation. This is accessed through the motor. So we say motor.transform.position, motor.transform.rotation, and finally we pass on the sequence number. That's it. That's everything you need to do for the server RPC. Now, as you can see, here is the catch. Whenever you want to add more inputs, you will need to manually add them here in the server RPC. here in the set inputs, so you pass the inputs from, of course, the input manager into the server RPC, from the server RPC into the client RPC. So now, as for the client RPC, we need to update the target state based on the server-authoritative simulation. So update client RPC motor.transform.position is equals to server position and server rotation. Then we will remove any confirmed inputs that we have. So as for the input buffer, we do input buffer.remove all, and x, if x is bigger than x.sequence number less than or equals to confirmed sequence. Finally, reapply the remaining buffered inputs. So we do a for each client input in input buffer, latest inputs equals to client input.inputs and process inputs. And that's it. Now, finally, we go to the process inputs method. As for the process inputs method, the only thing you need to change is you copy, or you can just cut everything that was previously inside the set inputs and paste it into process inputs. Then you want to uncomment, and the only change you will make is instead of using inputs dot, you will use latest inputs. Just like this, latest inputs, latest inputs, latest inputs, latest inputs, latest inputs, and that's it. You can save. Now we are applying server authoritative movement with client-side prediction. Whenever you make any change to the game, well, to your Locomotion controller, you can continue with the walkthrough that is provided inside Kinematic character controller. The only thing is that keep in mind, whenever you add inputs, you will need to first pass them from the set inputs method into the server RPC, process them inside the server RPC, and then inside process inputs, this is where you would normally write everything that previously was written inside the set inputs. And instead of using late inputs, you will now use latest inputs. That's everything that changes when you work multiplayer with Kinematic character controller. Now, let's test our implementation and see what we have. So remember, this is a server-client topology. You will run a server somewhere, clients will connect to the server, and the game will run. So if you want to, you can run your own dedicated servers or provide the code for players to run their own servers. So player 2 will join as a client. Check it out. We have the client rotating perfectly with the server and the client. Check it. Now, if we jump, both in real time, the server and the client are jumping. If we move, in real time, both server and client are moving. Now, I will position myself somewhere here and join as another player. And you can see both the server and the other client can see me rotate, and they can see me move. Everything at the same time happening for everyone. And this is movement with server authoritative movement and client-side prediction implemented for the Kinematic character controller. Now, as I promised you, I will now teach you how to do animations. So that's basically it. You have implemented server authoritative movement along with client-side prediction. There is still one more challenge, and that is animations. So in the next video, we will learn how to do properly the animations whenever you are doing server authoritative movement and client-side prediction. So now we will move on to the next video where we will do client-side prediction. If you have enjoyed this series so far and you want to see a complete course and you wish to see more content, then this is where I tell you to subscribe, like the video, and leave your comments. These are very much appreciated, and I appreciate you very much. And stay tuned, because eventually I will make an online course teaching you how to create a full game using Kinematic character controller, multiplayer, client-side prediction, server authoritative, all the goodness, RPG, 3D, all those things. All right, let's get on to the next video then.